Let's see. Sound is on. Video is almost there. So we're going to go first with functional group and see whether you guys could remember from last time. On the laptop. And all right. So these are just some of the more common drug, and I want you to give me the name of the functional group. Try not to look at your list, because if you look at your list, then what you're doing is just matching one to the other. So what is the functional group in 1, 2, and 3? And just write it down on the board and show it up to me in bed. Number 2 is a bit hard to see, but this oxygen here is bonded to that carbon. Number 1 is the thing that you usually drink. Yes.
So you usually drink alcohol instead of water. Yes.
Remember this one, that one is an acid because you've used it from 14A. Acid-base chemistry, that's your acid. So this is pretty close with an acid structure, but rather than hydrogen, it's bonded to another carbon. Right. So this one starts with an A, starts with an E, and starts with an E. Oh, sorry, not E, A. Bigger, please. Yes. Oh, number 3, not quite. Yep. Yeah, thank you. And I'm just right. Right up. So number 1, alcohol. Number 2 is ester. And number 3 is not an aromatic group because aromatic group is a cyclic where the alkene is all around the circle. This one is just an alkene. That's why I was going to put E before because it's called an alkene. Okay. A lot of these is just pure memorization. Let's see. Oh, let's do oxycodone. What is the name of the functional group of this one? So that's 1. 2, 3. This one is also starts with an E, K, N. Number 1 is like a holiday. Number 2, I have no idea what sounds like that. Oh, right. No, actually, ether is not a holiday.
Easter. It sounds like it.
Yeah. No, it's closer to esters, but yeah. Don't worry about the primary, secondary, whatnot. Yeah. Okay. Good. Two out of three is pretty decent. Decent. Yes. Thank you. Thank you. Can you write a bit bigger? Number three, almost there. I think everybody got number one and number two, and number three is correct. Close. It's a good guess. It's a really good guess. But this one here is ether. So everybody got that one right. Ketone. The next, oh, shoot. I made a mistake, sorry. It starts with an A, that's why. My bad, my bad. It was my mistake. Okay. So number three is amine. And we also have an alcohol here. And let's see if I have something else that we haven't asked yet. Yeah. Sorry. This one is specifically a tertiary amine because there's one carbon, another one, and three, so it is a tertiary amine. But use it if you just call it as amine, just fine too. Let's do this one. Risperidone. I think I've taken it before. I forgot what it's for. No? What is that? Oh, probably not then. It just sounds familiar to me. It sounds like something that I would have taken, but I guess not. One is that one. Number two is this one. Number three is that one. Okay. Number three, if you don't remember, that's fine. This number one is also starts with an A. Yes, it is an A. Two is an A as well. Three, this technically starts with an H. Oh, sorry. Let me put the circle in number three. Fluorine is a halogen, so that's my hint for number three. Thank you, thank you. Yep. Thank you. You'll see this one in pretty much all peptide bonds are these bonds. So proteins are made out of these. Number two is not. Number two is yes-ish, but the specific name for it. Yeah, thank you. So we have this one is an amide. Two is aromatic, which is a good guess. Cyclic alkene is aromatic. The last one here is haloalkanes. Technically, this is an alkene, so this is a haloalkene. Now let's just do alkane. And if you put down fluoro, it's also fine. You find, for example, Teflon is basically fluorinated carbons. That's why everything else doesn't stick to it. Okay, we're done with some reminder on the functional group. And I want you to draw for me the structure of propane. Propane is a thing that you put in the gas tank if you want to have a barbecue. The propane tank, thank you. Thank you. Close. Thank you. That one is right. What you draw is the one in lighter fluid. Propane is 3, so it looks like that. How about if I were to ask you to draw a cyclopropane? So propane is that. What is a cyclopropane? Try to figure out what you guys watch. Thank you. It means it's just cyclic. It's interconnected together. So what would it look like? No, because propane is 3. Propane is 3, right? No, there's 4 carbon there instead of, yep, that looks right. That one looks right. Yep, that looks it. So this is propane. Cyclopropane is just interconnected like that. Like cyclic. So how about if we go to somewhat that's easier? Let's do hexane and cyclohexane. Hexane is right. Thank you. That's the hexane. How about cyclohexane? No. No, that's 2 cyclopropane together. That's actually 5 carbon there. All the 6 carbon are interconnected together. Thank you. Yes. So hexane is 6. So cyclohexane simply means all of the 6 carbon are interconnected together. And you will get just that. So if I were to ask you a cyclopentane, what would it look like? Just pentane is 5, so it just looks like a pentagon. How about this one? Let's do. Let's increase the difficulty a bit. So let's do 1,1 dash dimethyl cyclopentane. No, pentane is easy. Cycloheptane, because we haven't done heptane. 1,1 dimethyl, so I have 2 methyl group in my last name is the cycloheptane. Dimethyl, so there's 2 methyl group. Cycloheptane. Yes. Yes. Hold on, can I see that again? I think there's 8.
1, 2, 3, 4, 5, 6.
Oh, okay. Okay. Is there any more board? Do you want to play with the board?
Sure.
Thank you. How many carbons is cycloheptane? Yes. So you have 7 interconnected ring, which is hard to draw. It's just uncommon shape. Heptane is 7, so I have 1, 2, 3, 4, 5, 6, 7, more or less like that. That's my cycloheptane, and I have 2 methyl in position number 1, so like that. It's a cyclic, so I don't really care where number 1 starts. So that's number 1. Let's do another one. We've done heptane, which is 7. Octane is easy. Let's do the one that's a bit harder. Let's do 3-ethyl dash 1,1 dash dimethyl dash. Oh, sorry, 2,2-dimethyl, not 1,1-dimethyl. It would be the same compound. Dash 4 propyl nonane. So the last name, which is the longest carbon chain, is going to be nonane, and this is your last name, and everything else here in the front is basically whatever hanger on, so anything that sticks to it. So this is your first name. So always draw the last name first. we've done propane, which is 3. We haven't done ethane, but ethane is 2, methyl is 1. That looks about right, I think. Yeah. Number 4, the tail is too long.
1, 2, 3.
Yeah. Yeah. Oh, do I have any more? I don't have any more board. There's one at the back, on the very back seat. So how many carbon is nonane? Oh, yeah, that looks good. That's exactly right. Wait, hold on. Can I say that again? I think number 4, 1 too many carbon. Close. So nonane is 9. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just going to go position number 2. There's a dimethyl. So position 2, there's 2 methyl. Position 3, there's an ethyl group. So 1, 2. And position number 4, there's a propyl, which is 4. 3. 1, 2, 3. Something like that. So 2, 3, and 4. This is a propyl. This is an ethyl. And this is 2 methyl. Hence, it's called a dimethyl. Yeah, so this is your main carbon, and then the first one is here, second's there, and the third carbon's there. Yeah. No, doesn't matter. Usually, convention is that if you can try to draw it so it looks like tetrahedral, then it's a preferred configuration or drawing, just because you retain some of the geometry as well. All right. Oh, you just erased everything there. Yeah. It's for clarity. So the 2, 2 tells you that both is in position number 2. You can have, for example, 2, 4 dimethyl, then it would be in position 2 and 4. Essentially, you want to make sure that it's sometimes you just want to have like a double check that there is 2 methyl group and they're both in position number 2. It's just a clarification. This is a propyl group. Oh, if it's a 3,3 diethyl, then I would have 2 of these. The di is a prefix for 2, essentially. So we'll do one more. You guys are getting it, I think. Oh, I just erased everything. Where am I? Maybe it's in this one? Maybe it is in this one. Oh well, doesn't matter. Let's do another practice. Oh, I have some over here. So let's do 3-methyl-butane 1-ol. Did we do this particular page or not? Not yet? Okay. 3-methyl-butane 1-ol. So now I'm including a carbon chain and a functional group ol, which is short for alcohol. So the last name is still the same. So last name is in the end. So you want to know this is your last name and this is your first name. Yep. Not enough carbon. Right. Then there's a kink there, then that's your last carbon. So right, so yeah. But you do need to give a line sticking out from, yeah. Because otherwise it just looks like it's sticking together. Yep. Yep, that looks right. Missing one carbon.
No.
Not quite. So butane is 4. So I'm just going to draw from the last name first. Butane is 4. So 1, 2, 3, 4. In position number 1, I have an alcohol. So that's position number 1. And position number 3, I have a methyl group. There. Right? Position number 1, I have an alcohol. And in position number 3, I have a methyl. And you guys are missing just one last stroke on the yeah, we're just missing one more there. So let's do the one. How about this one? 1,3,5 hexatriene. Or these two naming structure is equivalent, but one of them is just easier to pronounce. The other one is just easier to read. So hexa 1,3,5 triene. Ene. What functional group ends with an ene sound? Alkene. Thank you. And I think alkene is one of the lists that we did for practice today. So what is the longest carbon chain in this particular molecule? Hex, so 6, right? 1, 2, 3, 4, 5, 6. So that's our starting place. Yep. Yes. And do you guys have anything for me? Okay. So position number 1, 3, and 5, I have an alkene, and alkenes are double bond. So position number 1, I have a double bond. Position number 3, another double bond, and position 5, another double bond. There. Let's do the one on the above it. Oh, you guys done this one? Should be easier. Butane 1,4-diol, or 1,4-butane-diol. So again, this is an alcohol molecule. Yep. Thank you. Yep. Position 1 and 4. Yes, that looks right. I have an alcohol. Position 1 and too many carbon. Butane is 4. So what's that one is right. Yep, that looks right. Alcohol is OH, right? So you want to put the alcohol. It looks to me that there's only 2 carbon. So you have to give it a bit more. Almost. We're missing, it's a diol, so there's 2 alcohol in position 1 and 4. So as always, I'm just going to draw the longest carbon chain first. So 1, 2, 3, 4. So that's 4. Position number 1, I have an alcohol. And in position number 4, I also have another alcohol group. There. So the structure looks something like that. And the number of carbon is 1, 2, 3, 4. Right. Let's do the next one. Penta 1,5-diamine. Penta 1,5-diamine. So the longest carbon chain is 5, and in position number 1 and 5, there's 2 amine groups in total. Or there's 2 amine groups in position number 1 and 5. Thank you. Thank you. You do put the H2 in there. If you put the N on itself, it's a different functional group. Yes, that looks right. That looks right. Thank you. That looks right. Oh, hold on. NH2. Yes. So we have pretty good response for now. It looks right to me too. So we have 5. So 1, 2, 3, 4, 5. Position number 1, I have an amine, so NH2. And position number 5, there's also an amine group, H2. Usually, I try to make sure that it's a little bit clear that the carbon is bonded to the nitrogen. So I flip the sign around to have the nitrogen sticking to the carbon molecule. Just for extra clarity, which is what you'll see majority of the time. Okay. That's pretty much it in terms of nomenclature. If you're going to go to 14C, I imagine you would have to name these things from scratch, but we're not going to go there. Instead, we're just going to start with the easiest one, which is naming of alkanes. And you guys already have a feel in terms of how to convert the name into a structure. What we're going to do next is going to convert the structure into a name. So we're going to now do structure into a name. There are several rules that you want to know. We're just going to stick with alkenes and alkanes, cycloalkanes, and haloalkanes. The rule is, first, you want to distinguish which one is the longest carbon chain. So essentially, however you draw it before, you want to reverse the process. First, you want to discover the longest carbon chain, and that's going to be your last name. Okay. Number 2, you want to find all the side chains. Find the location of all side chains. Number 3, give it the smallest, give the location smallest first number. And 4, assemble everything alphabetically. Assemble alpha. Is there an H in alphabetical? True. Usually, if I'm not sure, I just like do that. Assemble alphabetically, exclude the prefix. I'll get to that a bit later, what I meant by excluding the prefix. And essentially, number 1 is just your first name, so try to figure out number 1 first. And then this is going to be your first name, and we'll do that kind of step by step. You guys copy it down? Almost? Yeah.
So even for the side chains, if they technically have less carbon than one another, we still arrange them alphabetically?
Yeah. The rule gets more complicated than alphabetical once you have stuff, because it's one of those things that the rule comes and then it's like, whoa, we have like more complicated cases, and now the rule as it becomes more complicated, the rule becomes more arbitrary as you go. It's a name. Names are always kind of arbitrary. So these are the rules. So if I have this particular structure, what's the last name? So what is going to be the last name? 6 is hexane. Thank you. Now, let's say I have a carbon molecule sticking out here and here. So what is these? So this is your locations of the side chains. And what is this group called? Methyl. and this is also the one at the bottom is also called a methyl. So I have two methyls. So it's going to be called a dimethyl. And the di here is my prefix. And what position should I give the methyl location supposed to be? 2 and 3. So I have go 1, 2, 3. Now I can also go from the right to the left, and if I go from the right to the left, I can give it 1, 2, 3, 4, and 5. But that makes no sense because 2 and 3 is smaller than 4 and 5, so I need to go and give it a locations of 2, 3 dash. And we simply have to combine everything together, so the final name is the comma disappears there. 2, 3 dash dimethyl hexane. And the name itself have no space in between. So the structure, let me clean up the structure again, just get rid of the notations and so on. So that particular molecule is called a 2,3 dimethyl hexane. So we simply reverse the process on how we draw from the name. Yeah? Di simply means two. There's two methyl group. There's two, and it's in position 2 and 3. If it's a 2,2 dimethyl, then it would look something like that. Then this particular molecule is now 2,2 dimethyl. Right.
You said dimethyl would be one word, but dimethyl and hexane.
Now, everything is, you put everything together without any spaces in between.
Oh, so it's dimethyl.
Yeah. It's just kind of a notation wise. It really comes from Morse code. You have to send this through Morse code, so there's no spaces there. Really, because the telegram costs more money if you put a bunch of spaces in between. Let's see. Let's do another one. How about the name of that molecule? Oh, actually, yeah, that's the name of that molecule. So what's the last name? Just shout it out. Octane. And what is that group called? That's a methyl. 1, 2, 3, 4, 5, 6, 7, 8. So methyl. And what position should I give it? 2. Now there's two ways you can count the number. I can go from here. So 1, 2, 3, 4, 5, 6, 7. So I can give the methyl in group number 7. Or if I count from the right to the left, I can count that this is 1, 2, and I can give it position number 2 or position number 7. It's going to be the lowest first number, so I'm going to give it number 2 first. So it is going to be a 2-methyl. And the full name, the complete name of it is going to be a 2-methyl octane. Yeah?
If you were to give us the name, if you were to give us 2-methyl octane and we drew it on the actual number 2, is that the same?
Yeah. So if you were to draw it, remember these things are floppy. So if you actually put them in solution, they kind of wiggles around like a snake. So if you were to draw it this way, it's still the same thing. If you were to draw it 3, 4, 5, 6, 7, if you draw it that way, it's still the same molecule. There's still the longest carbon chain still is 8, and it wiggles. So it's the same molecule in the end. Let's see if you guys could get the trick on this one. What is the name of this particular molecule? Remember, the molecules could wiggle. It's the same thing. Now, the best way to go to figure out the longest carbon chain is that whenever it branches, just give it a little dot so that you notice where it's branching. And then if you notice that this is longer, then you go that way. You notice that this is 2 and this is 1, so you move upward. No. No. So my point is that the longest carbon chain is actually going to be that, right? So that's just, it's the same question that you have. It wiggles around. So in fact, it is, the longest one is going upward. Well, put a dot, and you notice that this is 1, this is 2, if I go that way, and this is like 7, 1, 2, 3, 4, 5, 6, 7. So the pathway then 2 and 7. So this should not be the longest chain. Do you get what I'm saying? Just put a dot and figure out which one is longer, and that's the path of the longest carbon chain. No, the longest carbon chain is not 9. Yep. Yep. Missing a dash between the 3 and the number. Yeah. So if you can't see it yet, the longest carbon chain is actually 10. And that's what I meant by going this way and that way. So the longest carbon chain is 1, 2, 3. So 4, 5, 6, 7, 8, 9, 10. So the last name is going to be a decane. And yeah, since we know that this is, and the act of just kind of putting a dot on it tells you that, okay, the side change is going to be over there. Whoops, I just erased it. And this is a methyl group. And it's going to be in position number 3, so it's going to be 3-methyl decane. Okay. So far we flip it around. We put prefixes. Let's do another one that have 2 different functional group, and this is where the alphabetical makes a difference. Let's do a molecule that look again, if I want to, once it branches quite a bit, just gonna put a dot on it. It's okay. I have a branch here and I have a branch there. So where should I go to get the longest carbon chain? And this one here is a 2, that one's a 2, so it really doesn't matter. So in this case, the longest carbon chain is just going to go across the page. Right? And if you put the dot on it, it'll tell you where the locations of the functional. Yeah. So if I were to have, sorry. Since they're both 2, it doesn't really matter where you go, right? I'm not sure what you mean by 1, 1. Okay. Put a dash in between letters and numbers, put a dash in between them. So letters and number, put a dash between them. Letters and numbers, put a dash between them. So ethyl dash 4-methyl. So ethyl dash. Yes. So yes. Sorry, that one, the number is correct, but between numbers and letters, there should be a dash. Yeah, that looks right. Yes, that looks right. So this is the longest carbon chain is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 is octane. That's going to be the last name. And I have 2 things. This is a methyl, and this is an ethyl. And the ethyl is going to be in position number 3, and methyl is 4. So I have 3-ethyl and 4-methyl. And I have to assemble them alphabetically, disregarding the prefix. So E before M becomes 3-ethyl dash 4-methyl octane. And what I found quite a bit of an issue is just between a letter and a number, you always put a dash between a number and a letter.
So the only time you use minus is when you have to close your
Right, comma is between numbers and numbers. Number is a comma, number of letters is a dash. And letter, there's nothing in between. Okay, so let's do another one, something similar. And how do you name this one? There. There's no trick of left and right here, it's just going across. Close. There's 2-methyl. Yeah. It's a rule, so it's just. Yes. 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 Thank you. So I have 5-ethyl. And I have a methyl in position 3 and 4. I have dimethyl, di for 2. And I'm going to assemble them alphabetically. And the last one is I'm going to assemble them alphabetically, but I'm going to disregard the prefix. So I'm going to look at E and M, but I'm not going to look at the D in terms of alphabetical order. So this becomes a 5-ethyl dash 3, 4 dash dimethyl octane. Well, that's what I think too when I was learning this. It's just alphabetical. Okay. Later on, it's the thing is going to be weirder because you're going to go into molecular weight. Once the molecule becomes much more complicated, if you go it becomes weird. Okay. Any questions so far that you're not quite clear yet? I think most people are okay from going from here into a structure, but structure into a name seems to be a bit more challenging. It's just you get to practice. Okay. I'll throw. Yeah, I'll throw for you the trick. Yeah, this is as complicated as it gets, really. There. Okay. There. Just put a dot on wherever it branches. It will help you out in terms of figuring out where everything go. So maybe I should use something a bit more colorful than blue. But so that's where it branches. So it's the location that you have to. Oh shoot! Do you guys even know how to name this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So the last name is going to be 12, so it's dodecane. Undecane. Dodecane. Yeah. So no. You want to go. So I'm going to look at here. It branches here, right? It branches here. This is 3. If I go this way, there's 3. But if I go that way, there's 5. So I need to go to the longest one. Yeah. And then I go here. It branches again. This one is 2. This one is 3. So I need to go to the one with the 3. Yeah. So the pathway now is going to be that's going to be the longest carbon chain path. Yes, and add them up together. And then in the end, you get 12. You try until you get the smallest number. Right. So if you have multiple things of the smallest number, then you go the second smallest number and so on. Hold on, I haven't actually solved this thing. Yes. Can I see that again? You're missing one functional group. Yeah, in position 6, there's something else there. Yeah. Oops. My pen has stopped working. Oh, I can type it in. So you should find that the long... Oh, what happened there? Uh-oh, what happened there? So let me write it down. I have in position, if I were to go that way, is going to be the smallest possible number. So I should have in position number 4, for ethyl. I have 4, 5, 6 methyl. And then we also have the last one here, 7 propyl. Okay. So alphabetically, E, M, and P. So 4-ethyl dash 6-methyl dash 7-propyl dodecane. What's up? Yeah. The meth. Tetra is 4. It's if it's 14, then it's tetra. Tetra. No. That's a propyl. So it's just. Sorry. The propyl is that, right? So 1, 2, 3. Yeah.
I accidentally added the.
And it's not tetra. It would be a butyl. Yeah. It's like methyl. Yeah. Now, if you have multiple of the same thing, then you do di, tri, tetra, and so on. There should be an online exercise already on Canvas that I found online that you can type in the name. You look at the structure and you figure out the longest chains and so on. That's a really good exercise, both for the cyclo one as well as for this one. It would be a little bit on the harder side. Some of them are quite hard, but if you're comfortable with, say, 50-60% of it, then you're in pretty good shape. No. We'll do one last one, which involves sorry. This is as hard as you get. Yeah. This is as hard as you get. No. No, because we have a lot of things to cover. So one last example of the naming. Let's do a cyclic one. Let's do this one. Why not? So give it the smallest number possible. There. So in this case, if there's a cyclic, you want to give the last name as a cyclic molecule. In the cyclic one, it's easier to see the functional group, so these are the same. And that's also one thing. Okay. Yeah.
You have, because like if you do it the same way that you were doing these ones, you could make that.
You want to make sure that the number is smallest as possible. Yep. Smallest number, smallest first number. So you immediately would start from 1, for example, rather than...
No, I mean, like you, like if you start on the blue side and make your way over instead of making it into a ring, you can get 7 instead of 6.
Oh, I see. No. Your cyclic would dominate the structure. Yeah. Yep. No, not quite. Can I see your nomenclature again? Yes. Almost right. Almost. The numbering could be slightly smaller, and the order is off. Remember, we're disregarding the prefix. Disregard the prefix.
That's why I'm having trouble knowing where to start.
You try. So either it's 1, 2, 3, or 1, 1, 4, or 1, whichever gives you the smallest number possible, then it's going to be the right. Yes, you are. No. You want to go with the cyclic, longest cycle. In this case, the 6th cycle. Smallest number possible. No, it's if position number 3 is not going to be there. It's not 3. No. As long as you look at, if you arrange all the numbers from small to big, it would be 1, 2, 3, 4. It's like the smallest first number in that regard. Yes. It's not an aromatic. Yes. Beyond the scope of the class. It would actually have a different name altogether. No, after a while, you give up in naming it. Instead, you just draw it. Well, all the name comes from the fact that we didn't have internet before. So if you want to show somebody the structure, you kind of have to be able to give them over the telephone. Otherwise the mail takes you a month to go from here to Europe. So now it's rather antiquated, but yeah. By the way, the smallest first number possible is going this way. And I'll give it number 1, number 2, and 4. So if I go, is this clockwise or counterclockwise? If I go counterclockwise, my number would be 1, 2, 4. If I were to go clockwise, my number, the smallest possible, is 1, 2, 5. So I'm not going to go to 1, 2, 5, but instead in 1, 2, 4. So I have 2-methyl in position number 1 and 2. So I have 1, 2 dash dimethyl. And I also have a 4-ethyl. And remember the alphabetical, disregarding the prefix. That's why I choose methyl and ethyl, because people do switch around the D and the E. I'm looking at just the E and the M. So E before M, 4-ethyl dash 1, 2, dimethyl. Cyclohexane. Didn't have enough space there, but yeah. All right, so that's more or less nomenclature, and I think we're in okay for now. Let's take a short break. Any questions before I close the nomenclature for a bit? 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So we're always going to try to find the smallest number. After a while, you kind of like, oh, this is.